So thank you everyone for joining us. So today our guest is Abdullah Shah. He is a cloud and security architect with a track record of building highly scalable and mission critical applications for Silicon Valley top startups and Fortune 500 companies. He's currently working as a software engineer in Salesforce engineering team, and he is leading teams building cloud functional services in areas of network security, data engineering, and for different cloud environments. So Abdullah, welcome to the show. Really glad to have you here.
Thank you, Saad. Glad to be here.
Okay, Abdullah. So today we will talk about the importance of infrastructure as a code and how to get started with it. So we can't really think of a better person than you. I think you're the best best expert on actually advising on this. So let's just get started. So explain to us the concept of IaC and why should companies work with it?
Okay, so before we actually go into what IaC is, right, we need to take a step back and understand why there was a need to do IaC. Right? So historically speaking, the historical applications or the applications created in the legacy environments, right, on-prem servers and things of that nature. So every application that a company or a business has requires some infrastructure to actually operate it on, right? And that historically has been a very manual process where human beings are involved. You have to hire specific teams, professionals that essentially know how to manually configure each of these environments, right? Which in most cases are a set of servers that have ranging from network, storage to compute, providing services across these three pillars, right? And historically, all of this has been very manual. So each configuration server will have its own configuration. People will do it manually. There is going to be zero to, minimal documentation. And that leads to inconsistencies in the infrastructure itself and leads to environmental drifts. That is what it's called in the IT term, right? And that becomes a nightmare very quickly if you want to scale up. Because of human involvements, error rates are really high. And once something goes wrong, it's even more painful to revert it back to the right strategy, right? That's because there is no set steps or set processes that are actually followed to get there. That is where the infrastructure as code revolution, as I call it, is coming in. Right? Infrastructure as code, as the name suggests, it allows you to essentially deploy all of the infrastructure that was previously done manually by hand in terms of code. Right? What that gives you is essentially speed, consistency, and accountability. These are the three fundamental pillars of IaC. With speed, you increase your time to market. In terms of actually you reduce it in terms of getting more features to the market, you increase developer efficiency, you increase consistency across environments, reduce drifts, and you create accountability. Because all of your IaC is essentially version controlled and it's defined in terms of code. So you have full trail, you can fully audit all of the stuff that is happening, right? So you can pinpoint down to the lowest level of change in your infrastructure, maybe adding a new port or removing a new port. All of that is completely documented and audited so that in case of any errors or something's unknown, you have a way of going back to the desired state, right? And of course, there are a lot of other details that we can go into, but at a very higher level, the benefits include tremendous cost reduction in terms of operating your applications, increased in the speed of deployments, reduction in errors, improving infrastructure consistency, and above all, eliminating the environmental drifts and providing a full holistic view into how your infrastructure looks like.
Okay, that's great. So it seems like there are a lot of tangible benefits. So let's just assume I have a startup and I'm in the process of setting up an IaC. How do I get started? What should the process be like?
Okay, cool. So I think first startups, or as a matter of fact, any company, right? who's diving into the realm of exploring IaC, they first need to identify what are the infrastructural needs, right? What are they trying to build? What does the product look like? What is the application infrastructure that is required to run the product, right? Once all of those questions are answered, that is when you can essentially make a categorical decision, what is the process that you're going to follow, right? So again, there is a wide band of different ways where startups or different companies work, right? Some companies have an idea of just quickly rinsing and repeating, building up something quick and pushing it to market, right? In those cases, maybe infrastructure as code investment at the very start might not be the right thing to do because you're trying to create just some prototypes. On the other hand, I can argue that having a solid foundation where you actually start all of the things with the right mind and with the right IaC principles, you can essentially create a foundation that you can scale once you try to move beyond the first 2 or 3 servers, right? And again, for startups, start with the audit of what do you actually want to do, what your deployments look like, democratize the process of IaC across devs and all of your stakeholders, right? And I would just say implement it from ground up. That will save you a lot of trouble moving forward that I have seen companies face, right? And that's the general idea. Evaluate, audit what you need, and then come up with a strategy to actually embrace IaC or have it on the roadmap that you will immediately focus on as soon as your first version of the products go out.
Let's just get a bit deeper. What kind of trouble that they will get into if that IaC is not actually implemented?
Right. So I think a few of the stuff ties back to my earlier conversation that I was saying, right? That if IaC is not implemented, then a lot of the infrastructure that you have to maintain is going to be manual. You have to hire human beings. If you don't have the right professionals, you will have to have your developers wear the hat of actually doing manual stuff. And every time you do manual stuff where code can be used, it's going to create problems in the long run, right? And if you are just a small startup with 2 people and you say that we can't afford investing in DevOps at this time or IaC, then it's fine. Sure, you can create some prototypes, right? But if you have to create 10 more servers, if you have to create more deployments, if you have to create faster iterations of your product to go into the market, you need a repeatable and robust IaC strategy, which allows you to create those features, push them securely and robustly through your IaC infrastructure and get them to customers, right? This process of having manual things will not scale beyond the first 5 to 10 servers. It may, but it will require a lot of pain.
Okay, that's great. So in terms of DevOps and having a DevOps culture or a system in place, is IaC and DevOps connected, disconnected? Do they go together?
Right. So good. So I think the DevOps and IaC go hand in hand. So in traditional words, right, a DevOps still existed when there was no IaC. The idea is that once you develop applications, you have to operationalize those applications, right? You will have to make sure that they run smoothly. And that is where DevOps comes in. Historically, there has been SRE teams and DevOps team that is specifically there's a line between developers, they hand off the artifacts to the DevOps teams, and they essentially do manual deployments and all that, right? With IaC, that part has been shifted a bit left in my mind, right? So there are different strategies. There are still different schools of thoughts. The primary 2 being the ones where you have an SRE model, where there's a handoff between the devs team and the DevOps teams. And the other, which is the more popular one and increasingly being adopted, is the shift left model, which also translates to the service ownership model, where you shift the DevOps or the application operations to the left. That essentially means to incorporate that in the process of software development lifecycle. So your developers have to have the right mindset that whatever we are developing, we have to make sure we have the right infrastructure to operationalize it. And developers love working with IaC because it's code, right? And that is what they know. And that is where you create this one holistic view of your app development, to your DevOps, to your monitoring, all of that, which is primarily enabled by IaC.
Okay, that's wonderful. So obviously, just in continuation of this coding, now coming towards testing and monitoring IaCs. So do I really need to test it, or what should be kind of structure in that needs to go in there?
Okay, right. So I think, yes, we absolutely need to test and monitor IaC. Right.
Okay.
There is no substitute to testing. IaC is not something magical that is going to take away all of your testing needs or monitoring needs. If anything, it encourages you to actually be more stringent towards testing requirements and have a test first methodology. Right? And there are different levels of testing required to cover all stages of an application from an IaC deployment point of view. Right? So you have to make sure the correctness of the IaC templates that you are using. You have to make sure there are no misconfigs that can deal you a lot of pain once your applications are actually deployed on that infrastructure, if there are misconfigurations, right? You have to have application code to be mocked. You have to have unit test, integration test, and infrastructure as a code testing strategy. And there are different tools out there that actually enable that. But the fundamental notion of testing being critical for IaC cannot be overstated. It is
Okay, let's
really
go a bit deeper. So some of the experts would say that there is no need for a QA operations in a pure DevOps culture. Is this the case? And who's actually doing the testing? Is it like the QA team? Is it like the coders themselves? What's the strategy for it?
right. So this is actually a very deep topic that we can spend a lot of time going into, right? But historically, QA has been its own function where people just say that, okay, I've done my development, now you do QA, right? That does not really fly in this modern agile work and with the IaC concepts being coming in. Why that does not work is because since you are automating a lot of your continuous deployment, it's essential that you have automated integrated tests that you can run before your deployments are rolled out, right? Because when we embrace the notion of CI and CD, what we are essentially saying is that we want to keep up with the pace of our developers or the features that we are actually creating and pushing them, and we want them to be immediately deployed, right? Once you do that, this means there are going to be continuous updates to your application infrastructure and applications. And once that happens, and all of that is automated, if you do not have automated tests, you can get into a lot of trouble, because if you roll out a production version which has not been tested properly, things can go messy very quickly. Right. So it's imperative to define an testing strategy across all stages of software supply chain, right? Starting from the sources that are used to actually build the software, the infrastructure as code that essentially allows you to do continuous deployment and continuous integration, right? And integration tests. You have to go with the concept of blue-green deployments. This is just one buzzword, but essentially what you're saying is that whatever I'm deploying out there, I need first to confirm that this is the right version and it is not going to give me any degradation in my application. So that is that. I hope that summarizes things. But in this fast-paced environment, testing is critical.
So we can summarize that maybe the QA guys who are just doing QA are in trouble with this approach.
So that's a good one. The idea of that I mentioned, right, that the shift left and the notion of service ownership, that essentially means that you own the end-to-end life cycle of an application developer. This means that if that means that your application is going to be deployed consistently, and if you do not have the right tests to test it before it gets deployed, then you're in trouble because you are the service owner. There is not a QA function that is going to help you with that. So, of course, this is a bit more nuanced than that, right? This is, of course, the North Star that, okay, everything is service owned and you have the ability to test each and everything. In reality, it's a lot more complex. Your services rarely work in isolation. They work collaboratively with a bunch of other services and ecosystem across different organizations and business units within your company, maybe with third-party services as well. So the integration tests that actually define your full product might still be a separate layer, but all of those have to be automated and implemented, right? And it comes down to different use cases of whether you want to have a dedicated QA team, whether your application infrastructure is so huge that it's just not possible for individual service owners to test everything on their own, which I believe that with the right amount of effort, you can still do that. But it does not rule out that you can't have a QA function. You can have that, but the grunt work or the major legwork has to be done by the service owners.
Okay, that's great. So now coming towards, so there's this fear of automation with IaC, because in the end, there are physical components involved, there are hard disk and there are network issues, things like that going down. And we have recent incidents where things have gone down. So how do you sort of mitigate this fear of automation?
Short answer is going to be testing, right? The idea is very simple. The premise of cloud and cloud native is that failure is not going to be an exception. It is going to be a norm. You have to anticipate failures. You have to model the state machine of your software, your application, the full infrastructure, that what can go wrong. And once something goes wrong, what is the series of steps that you have to take, right, to make those things go right? That is where again, I can't stress enough the testing criticality of the things in the IaC world, right? You have to design services from ground up, anticipating failures at each point, at each integration point, as well as during the code execution, for example, in different services, right? And once you model that state machine and you know what can go wrong, and once something goes wrong, what you do about it, is then when you have a robust testing strategy and you can get out of the fear of automation, because now you anticipate things to fail and you know what to do when things fail. And it's equally important to have a feedback loop from all of this, right? So if something has gone wrong, you couldn't catch it because maybe your test did not have the right environment to run on. It's imperative to have a control loop to find out why this wasn't caught in the first place, right? And then essentially specifically add a test or a framework that catches that, right, for the next time, right? That is the only way to continuously and iteratively improve. There will always be things you will miss, things will fail, but what learnings that come out of those failures must be incorporated in an automated way for that pain to be reduced moving forward.
Okay, that's great. Now let's just get a bit deeper into IaC and IaCs. So there are different approaches of it. I think there's declarative versus imperative. Can you please talk about those and get into details of those?
Yeah, so I think so both imperative or declarative, I think these are just mechanisms to implement IaC, right? So IaC is a broader and larger concept, right? Mm-hmm. And there are different ways to achieve IaC, right? Mm-hmm. The most popular one, or the ones that were initially started, all of these, right? So for example, Terraform, right? So these things work in a declarative way. Why they work in a declarative way? Because it's easier to maintain state, and state maintenance is a very critical aspect of IaC. So the infrastructure that you actually deploy, you have to have a source of truth of what is actually deployed on the substrate. That is what state is called. And it's easier to manage that state if you use a declarative approach to declare your resources, right? Having said that, there are cons and pros for these things, right? Con being for the declarative approach that the usual imperative programming control loops or conditional statements that do if, this, that are a bit tricky and hard in the declarative model, right? And that's somewhere where software developers or programmers get taken aback because they can't do the normal stuff that they're used to doing in their own daily imperative languages, right? So there are a bunch of tools that essentially exist that create abstractions around these declarative mechanisms to provide an imperative layer, right? So for example, Pulumi is one tool that creates this imperative abstraction on top of their declarative model. So Pulumi is self-declarative, but they create an imperative layer on the top, which allows users to do control loops or for loops to essentially create infrastructure, which would have been harder if it was just a declarative approach, right? So there are other things, for example, Cloud Development Kit, Amazon CDK, right? That is essentially another imperative thing, which renders CFTs, which are declarative, right? And now there is CDK TF, which essentially is Cloud Development Kit for Terraform, which again is imperative abstraction, but behind the scenes renders declarative Terraform templates. So it's more about the concept being IaC and choosing a technology that fits best according to your needs, right? I personally am a proponent of Terraform. I have worked with it for a long time, and it's a very vibrant community. It has lots of cool templates already done. But again, there are lots of tools, right? So you can evaluate different pros and cons, but ultimately IaC is a larger concept than just technical.
So with these approaches, which one can help any company with a technical debt?
Right. So again, so technical debt again ties back to the practices that we employ while we build our application code, right? Maybe there was a need of immediate customer deployment and you incurred some technical debt, right? With IaC, irrespective of whether imperative or declarative, right? What you get is, if you have the right amount of automated testing, is that your technical debt incurring is hard, because you will have rules in place that for each new feature you add, you must add a particular test, right? Things of that nature. And that's where the technical debt can get reduced. Of course, things like, okay, badly written code or code that requires refactor, if you consider that as technical debt, there are ways to catch that as well, but that is not as critical as versus missing things in testing, right? And IaC helps you create those guardrails around those processes where you can enforce testing requirements, and that reduces the technical debt overall.
So, Abdullah, when it comes to concepts like mutable and immutable infrastructure, how do they fit in this IaC?
Right. So mutable means changeable infrastructure, right? So in some low-scale use cases, or when you are just creating some prototype, right, it might just fit to create infrastructure, like if it's just 2 or 3 servers, which you know that you can quickly update and upgrade and create a new version or revision of the product that you are trying to get to market, right? Then it might work, right? And that's where mutability comes into place, right?
Mm-hmm.
But anything that you go beyond like 10 servers, right? If you are planning to create faster releases and all that, right? That's where the immutable infrastructure comes in. And immutable infrastructure is powered by IaC. What that essentially means is that once you deploy something, right, to release a new version, you rip out the full infrastructure and create a new one. This opens up possibilities like creating another stack of the same deployment, creating canary rollouts, or splitting the traffic in a controlled way to the newly created environment. And only when all of your tests pass, then cutting over fully to the new environment and destroying the old one. Like that's where the immutability principle comes in, that your infrastructure is immutable. It goes down in one shot and it's updated in one shot. But at the same time, it happens concurrently, right? So you have 2 parallel stacks going up and you roll out traffic to one, and once all of the things are satisfied, you tear down the old one. You can still have mutable deployments with IaC as well, right? For example, if you can have rolling upgrades, right, where you have 5 servers and you upgrade one after the other, etc., right? But that comes up with the cons of reduced operational capacity. Like, for example, if you do rolling and you have 5 servers, your first server goes down, now you have 4 servers remaining. So your capacity is reduced for your production traffic. Now the first one comes up, the second one goes down to be upgraded, right? So that's where there are differences between mutable and immutable infrastructure. And it becomes a nightmare once something goes wrong and you have to redeploy, right? And with rolling approaches, now even your getting back to the right version is scattered across these downtimes, right? So it balloons up quickly. So there are different approaches, right, to minimize these things, but if in doubt, go with the immutable.
So now, Abdullah, let's come towards the implementation part of IaC. So which tech stacks would you recommend, and which were the best options out there?
Right, so there are different tools to actually enable IaC, right? In terms of purely IaC itself, right? So CloudFormation, Terraform, CDK for TF, Pulumi. I personally think Terraform is one of the best tools out there because it has an early advantage in terms of early mover advantage as well. And it has a very vibrant community, a very well-written documentation, simplified syntax. And it's increasingly becoming a hot source for top startups to actually deploy their infrastructure or their services as well. So Terraform has a notion of providers where you can register yourself as a provider and then have your implementation done, and then people can use Terraform to use your specific constructs to interact with your services and your offerings, right? And again, this goes back to the point of what is the strategy and what is the decision that actually goes in selecting all of these tools is what are your actual use cases, right? What are your dev teams comfortable with in terms of using the IaC technology, right? Terraform is just one example. But I think there is a key aspect here is that IaC is not the only thing that you need to actually have a fully functional end-to-end robust DevOps pipeline, right? You actually need different actors and orchestration layers that actually apply this IaC to code and the code templates that you have actually written, right? There are different solutions for those orchestrations. We in the past, when there were no publicly available orchestrators, we had custom Jenkins pipelines and things of that nature to actually orchestrate all of our CI and CD, right? These days, there are a lot of different things. You have a concept of GitOps, which is triggered by GitHub Actions or AWS code pipelines, different orchestration mechanisms that essentially allow you to have a robust IaC pipeline. Right. Another important popular open source tool is Spinnaker, which was actually open sourced and developed by Netflix. And Netflix is one of the pioneers in cloud deployments and cloud native application building and releases. They do thousands of deployments and releases in a single day. And that's where they have pioneered this to orchestrated tool as well, which is called Spinnaker, as I mentioned, right? And in addition to orchestration tools like Spinnaker or your custom Jenkins pipelines or your workflows, you essentially need to have different orchestrators across multiple service teams that you have across different organizations and different business units that your company might have, right? Of course, this applies more towards enterprises where you have complex teams and scalable teams where you need these foundational services to work together, right? Which could mean provisioning the network infrastructure or the secrets management solution or the logging or audit trails and all that. But ultimately, IaC on its own just is a tool to enable you to deploy these infrastructures. You need to have well-defined orchestrators and well-structured blueprints of how your environment is going to look like and how IaC code is actually orchestrated and executed by those orchestrators.
So Abdullah, consider that I have a startup. I am building an MVP. I have a monolithic application. Okay. Uske liye what kind of tools that you would recommend me to work with?
Okay, so so you mentioned this is a monolithic application and a startup, right? So of course, there are different constraints of different startups in doing the right thing, right? So if that monolith is working and you need more features going into market and it's simple enough where you can just use manual configurations and things, then maybe that is the way to go, right? But if it's at a medium scale, or if you want to roll out features more fast or have better integration tests and decoupling and all that, right, then you essentially need to move towards the IaC pattern. And what IaC allows you to do is, so for monoliths, there is a specific pattern called strangler pattern, where you essentially start at the edge of the monolith and slowly come down to the core, right? So you decouple monolith functionality out of the main monolith and create it into smaller pieces, right? So for example, just create the component that maintains a session, right? Or maintains just the authentication, right? Pull that out, right? Maybe there is another code inside that monolith that does all of the secret management and secret fetching. Pull that out into a separate foundational service, right? And that is a good way to essentially get rid of the monolith and create decoupled, independently performing services, which are independent of the core business logic, and things won't go down burning in one shot. Right, so that's just one way of doing things, but essentially you have to define a strategy of how you want to decouple your monolith first, right, in terms of functionality, and then build your IaC strategy around it. That, okay, now you know what are the decoupled services that you need for your monolith or your application to function. Let's see how to orchestrate these foundational services through different tools and using IaC to increase the flexibility of achieving that.
Okay, great. So in terms of provisioning, does IaC help?
For sure, right? So we've talked about different ways and different orchestrations, right? So IaC, both your CI and CD can benefit from this, right? Specifically, provisioning relates to CD, right? I mentioned earlier in our conversation that GitOps is a new technology that is taking off, right? What that essentially means, it is built on the premise that all of your infrastructure as code is version controlled and is stored in a centrally monitored and maintained repo, right? And if something changes, let's say in your feature codes, right, there are automated actions that take place to validate those changes, test it, build the artifacts, and then essentially push those in required registries. And then your GitOps actions actually trigger your CD part. So now you are essentially decoupling CI from CD as well, right? And once the CI is done, your artifacts are generated, your CD kicks in, and that CD actually knows how to automatically take the configurations, take the artifacts, and deploy them in your target substrates, right? So Argo CD is one of the hottest technologies these days out there that works specifically with Kubernetes-based deployments. But there are other technologies as well that allow you to do CD, right? Spinnaker, you can deploy your custom IaC technologies to do your CD. AWS has code pipeline and code deploy that does all of that stuff for you. But at the end of the day, IaC facilitates everything from integration to deployment. So provisioning is one aspect of that as well.
Okay, so just for the audience, if you can maybe go the topic of CI and CD, maybe just explain it a bit.
Right. So CI essentially means continuous integration, right? And CD is continuous deployment. Continuous integration, what does that mean, right? Historically, you created an application, you have some source code up there somewhere, right? If it's in a repo, then you're already making good strides, right? But the idea is once you have source code of your application, then there are different people or different things that contribute to that source code, right? And it becomes increasingly hard if you do not have a continuous integration strategy to keep track of what changes are coming in, what is breaking something, what is a new feature that broke something else. That's where continuous integration comes in, that as soon as there are new code pushed to the source controls, right, you need to have an integration strategy that actually tests the viability of those post changes with the existing baseline that you have, that, okay, this is how things work. And I'm going to test these things once they come in. So that might involve building or compiling your applications, running all of the unit tests, maybe even running integration tests, right? So all of that becomes the continuous integration. And even the deployment artifacts that are created out of those source code is continuous integration, right? And then the continuous deployment is that once all of this build process is done, okay, people have created their check-ins, code compiled, artifacts generated, how do you actually go about deploying all of this in your target substrates, right? That is where CD technologies come in, right? So Argo CD is one example that I mentioned. There are other AWS Code Deploy exists, Spinnaker exists, where you can define your custom pipeline stages and workflows that, okay, first deploy on this, then make sure the percentage of traffic is going to the new deployment. If it's all good, then cut over to the new deployment, delete the old one. If something goes wrong, then just reroute the traffic to the original deployment. All of this comes under the CD umbrella.
Okay, wonderful. So now coming towards, so there's IaC on cloud and there's IaC on prem. What are the challenges? And do you believe IaC on cloud is gaining traction?
Okay, so IaC on-prem, right? So we have to fundamentally understand the differences between on-prem and cloud environments, right? So on-prem environments are not very standardized, right? Of course, there are standardized. Okay, you can say that I have VMware servers or OpenStack servers or things of that nature. But largely, the services that you deploy to enable applications, right? So your identity services or secret services or network security or all of that, right? These are very heterogeneous on-prem environments. There are tools that exist to do automation, right? Like Puppet, Chef, Ansible. So these things do allow you to do some sort of IaC on-prem as well. But because of the limited nature of scope that they operate in, and the services that are available to them, which most of the times have to be custom services built on, it can't be scalable and it can't apply to the general technology constructs, right? Cloud, on the other hand, gives you a lot of flexibilities. They have standardized way of defining how services would look like. They have repeatable ways of scaling out, scaling in infrastructural resources, right? They have great documentation, how things work, best patterns, best practices, and all of that can be abstracted away with different IaCs, right? So now IaCs have a repeatable and predictable environment to work against. And now you can build abstractions on top because you know that the underlying things would be repeatable, and you can create complex abstractions on top to enable very complex deployments, ranging from simple to very complex deployments as well, right? Of course, there are nuances between, okay, AWS is different than Azure or GCP, but at the end of the day, fundamentally, it is all tied down to network, compute, and storage, right? And different cloud providers work off of these three basic constructs to create their services and offer them and package them in different ways. But fundamentally, they all allow you to provision network, provision compute, and have storage for your applications. And that is why the IaC on cloud takes off, because you have this repeatable set of constructs that you can use to build complex infrastructures on top.
Okay.
So Abdullah, I have a startup, okay, and I'm looking for IaC profiles, and I'll start this process. What kind of profiles should I look for?
Right. So broadly speaking, there are two profiles, right? So there is pure DevOps and SRE, and there is the shift left model that we discussed about, where the service ownership is with the software devs for operationalizing the applications itself, right? So this depends on the stage that the startup is in, right? And if we are moving from very early stage, like maybe some manual SRE based stuff is okay, but moving forward where you're going to a mid to a growth stage, right? That's where the mindset of shifting left comes into picture. And that's where you need software developers who have the right mindset, that they have to do the operations for their service as well, which is enabled and powered by IaC and different technologies that exist to actually run your services in a robust way. So SREs and software devs with the DevOps mindset are the two profiles, and the latter is the one that is the preferred approach and increasingly the in-demand skill set in Silicon Valley and across the world as well, where there's a cross between pure software dev and the DevOps.
Okay, this question might be a bit difficult to sort of summarize, but anyways, what are some of the best practices in building IaC?
Yeah, okay. So I think there are different ways to build application structures, right? And again, it depends on the application itself, like what are the goals of that application. We can take a simple example. Fundamentally, you still need networks, compute, and storage to do anything on a cloud-based environment, or for an application for that matter, right? Production grade application, right? So assuming that we have a simple application that consists of just a load balancer, some servers to do some stuff, maybe some Kubernetes-based containers, or some storage databases, some monitoring solutions. So to building an application infrastructure for this sort of a typical app, specifically in the agile world of IaC and best practices, requires a set of foundational services at the periphery as well to enable all of this. Right? So you need network security services that actually configure and secure your network. You need identity services that essentially help you create identities for your services and users. You need secret management solutions. You need centralized logging solutions. You need threat detection. You need software supply chain security at the source, where you essentially create application static testing. You have to have runtime monitoring to detect threats and incident response if something goes wrong, what you need to do, right? So best practices generally mean a full shebang of all of these foundational services that you have to create that actually go down to enable the application itself to function correctly.
So Abdullah, let's just wrap it up. So obviously you are an expert. So summarize infrastructure as code for us: the good, the bad, and the future.
Okay. In terms of good, right? Increased flexibility, consistency, accountability, right? Agility, faster time to market for new features, secure software development lifecycle, monitoring, security, cost reduction. All of that comes built in once you actually have a structured way of implementing IaC for your company or your business, right? And the only thing that is going to happen is it's keep going to get better, and it's already saved a lot of money to different companies when they have implemented the IaC in the right way. It has eliminated the manual need of configurations, and it has sped up the process of software development itself from integration to deployment, and ultimately delivering business value to the customers, because that is what the ultimate goal is. And IaC helps you create and serve those customers in a very fast and agile and repeatable way, right? In terms of bad, I think with great power comes great responsibility, right? IaC enables you to supercharge your software development lifecycle and product creation, right? But at the same time, if you do not pay the right attention to build the right guardrails and the right foundational services around your infrastructural environment, for example, things like checking for common misconfigurations or open ports or mounting the wrong things in your containers, right? All of these things essentially increase your footprint of security vulnerability or a security attack waiting to happen, right? So it's imperative that you have the right mechanisms to continuously audit and improve your state of infrastructure, which is defined by code in this case, right? So do all things to essentially prevent misconfigurations in your infrastructure as code. In terms of future, right? Companies increasingly are competing against each other for faster time to market and deploying new features and new products to customers. Customers have increased demand, and the old way of doing manual DevOps just simply doesn't scale. And you are bound to lose customers and businesses if your competitors are moving faster and putting their products out to market way faster than others, because they have better IaC technology and better IaC infrastructure in place to enable those fast repeatable deployments and product iterations, right? That's where the market is going, and I very strongly believe that that is where all of the future or the transformations of the current companies for the next step, which they're hoping to get to, should have IaC with a full robust orchestration infrastructure and pipelines at the heart of their businesses.
Okay, great, Abdullah. So thanks a lot for your time. So whenever you are here, this part of the world, we would love to have you over here at our office. So again, I really appreciate your time and all of your expert opinion.
Right. No, thank you so much for having me, and looking forward to be there as well. And yeah, thanks for having me.